Congratulations everyone to my channel. Okay, here is the problem of determinant and with the related with the properties of triangle. It is given that A, B, C with the angle of a triangle. Okay, then calculate the simplest value of this determinant and show that this is purely real when and only when sine thrice a plus sine thrice b plus sine thrice c is equal to 0. Okay, now first we write this determinant and simplify by the expansion rules. Okay, this is e to the power ia and e to the power ib, e to the power ic, e to the power ib, e to the power ic and e to the power ia, e to the power ic, e to the power ia and e to the power ib. Now expand this. This is ia, this into this is I into c plus b, this into this I into twice a. Okay, then minus e to the power ib and these are cancelled, so minor are this into this into this e to the power, so ib 2b minus e to the power 2b 2ib and e to the power I into a plus c and e to the power ic, and this first and third column is cancelled. Multiply with this, then we got e to the power I within bracket a plus b and minus e to the power I into 2c. Okay, and now again multiply this, we got here I into within the bracket a plus b plus c, and if we multiply same as if we multiply this here, we got here same figure, that is 3 times of that, so these and this figure are same and also this figure are same, and the other is e to the power 3a into I, e to the power 3b into I, e to the power 3c into I. Okay, since this is 3 times of e to the power I into pi and this is here e to the power 3ia, e to the power 3b into I, e to the power 3c into I. Since as ABCD the angle of a triangle, so you can write this sum of the 3 angles is equal to pi, and that's been 180, and this is here 3 times of, this is e to the power ix, it means cos x plus I sin x. Since, so for that we can write here cos pi plus I into sin pi. Okay, and for that this is equal to cos 3a, for that cos 3b and cos 3c, and taking common minus, that is sin 3a, sin 3b, sin 3c, and this is cos pi is equal to this is pi minus 1, this is pi minus 1, so this is there minus 3, this is there minus 3 and minus of cos thrice a, cos thrice b, cos thrice c, minus I into it is given 0, since sin thrice A sin thrice B equal to 0. This is minus 3 minus, taking common minus, then 3 plus cos thrice A plus cos thrice B plus cos thrice C, which is real when and only when and only when sin thrice A sin thrice B sin thrice C equal to 0. This is proved. Okay.